Welcome to Fluid Coding and AI. A domain agent demo can look enterprise-ready before it is actually safe to trust. Today, we are reviewing one airline customer service agent template like real software, asking where it has workflow boundaries and where the production contract is still missing. The useful question is not, can an agent answer customer service questions? The useful question is, can this template cancel a flight, change a seat, issue compensation, and handwork between specialists in a way an enterprise could audit, test, and govern? That means we are looking past the happy path. We are following side effects, data assumptions, handoff ownership, guardrail placement, eval coverage, and the moment a demo crosses into accountable software. The template under inspection is OpenAI's Customer Service Agents demo. It uses a Python backend with the OpenAI Agents SDK, a Next.js interface with ChatKit, and 6 airline support agents: triage, flight information, booking and cancellation, seat and special services, FAQ, and refunds and compensation. The inspected clone was a public demo repository, not a private production system. The research found mock airline tools, mock passenger context, input guardrails, handoff relationships, and UI events for orchestration. It also found no public eval, benchmark, or test suite artifacts in the code. For this review, enterprise trust means more than a good prompt and a friendly chat interface. It means a domain boundary, a data contract, a tool contract, a handoff contract, an eval contract, observability, recovery behavior, and governance ownership. That sounds heavy, but it is practical. If an agent can mutate records, spend money, expose personal data, or make a customer promise, somebody needs to know what it was allowed to do, why it did it, and how that behavior is regression tested before the next release. The demo has a real route map. Triage can send work to the right specialist. Specialist agents have domain prompts. Some flows chain lookup, decision, handoff, and action. The delayed connection example is the strongest pattern because it shows an agent recognizing a travel problem, finding alternatives, and moving the task toward rebooking. The enterprise gap is that routing is not the same as a workflow boundary. The research did not find a durable state machine for allowed transitions, retries, rollback, terminal states, or compensating actions. The data model is intentionally demo-shaped. The context includes passenger details, confirmation numbers, seats, flights, accounts, itineraries, baggage claims, compensation cases, vouchers, and special service notes. Some public context fields are filtered before display. That is fine for teaching. In production, context is an access control problem. The template does not show a tenant model, customer identity verification, personal data classification, consent, retention, lineage, freshness labels, or a rule that says which agent may see which field for which task. The most important test is to follow the side effect. In the demo, tools can book a new flight, cancel a flight, update a seat, assign special service seating, or issue compensation. They mutate in-memory context or produce mock confirmations, cases, seats, and vouchers. The tool list is domain-specific, which is good, but a tool list is not a permission model. The inspected source did not show per-tool approvals, authorization middleware, policy-bound credentials, idempotency keys, transaction limits, rollback handlers, or signed action records. The template does include input guardrails for relevance and jailbreak attempts. That matters. A customer service agent should not drift into unrelated tasks, and it should not leak system instructions just because a user asks cleverly. But OpenAI's guardrail docs distinguish input guardrails, output guardrails, and tool guardrails. Input guardrails run at the front of the chain. Tool guardrails run around custom function calls. If the risky moment is a cancellation, refund, or seat change, the guardrail needs to protect the tool call, not just the first user message. Enterprise autonomy does not mean the agent never asks a human. It means the system knows when a human is required. OpenAI's Agents SDK now supports human-in-the-loop approval for sensitive tools, including pausing execution, surfacing pending approvals, serializing run state, and resuming after approval or rejection. That pattern is missing from the inspected demo's side-affecting actions. For a real airline workflow, cancellation, compensation, medical seating, and high-value rebooking need risk-tiered approval, stronger verification, or both. Handoffs are one of the best parts of the template. They make the system feel like a support organization, not one giant prompt. Triage delegates, specialists take over, and agents can return work when the request is outside their scope. The enterprise question is ownership. What state must exist before transfer? What context is allowed to cross the boundary? Does the receiving agent validate the handoff? Who owns the next decision? And if the handoff fails, loops, or conflicts with another recommendation, what state does the customer end up in? The trace tells you what happened. The eval tells you whether it was acceptable. OpenAI's tracing can record model calls, tool calls, handoffs, guardrails, and custom events. OpenAI's agent evals guidance points toward datasets, graders, eval runs, and trace grading. The public template is helpful for showing events, but the inspected clone did not contain golden task suites, adversarial prompt suites, tool call assertion tests, permission tests, or handoff regression tests. That is the biggest trust gap because a demo proves a path. Evals protect behavior after change. Security frameworks now treat agentic systems as their own risk category. OWASP's 2026 Agentic Application List calls out goal hijacking, tool misuse, identity and privilege abuse, insecure inter-agent communication, memory poisoning, cascading failures, and human-agent trust exploitation. Those risks map directly onto this kind of template. Compensation and cancellation map to tool misuse. Handoffs map to inter-agent communication. Missing credential boundaries map to identity and privilege. A polished chat answer maps to human trust, because users may believe the agent had more authority. This is not academic. Microsoft says more than 80% of Fortune 500 companies use active AI agents built with low-code or no-code tools, based on Microsoft first-party telemetry from November 2025. Microsoft also says 29% of employees have used unsanctioned AI agents for work tasks. Other 2026 research summaries point in the same direction. Agent adoption is moving faster than identity, monitoring, and approval controls. So the template question matters because teams are already turning demos into internal tools. There is a fair counterpoint. A demo template should not be judged as if it were a finished, regulated enterprise product. The OpenAI repository presents itself as a customizable demonstration. It uses mock data on purpose, and the broader SDK provides tracing, evals, tool guardrails, approvals, durable run state, sandboxing, and other production-facing primitives outside this specific demo. So the verdict is not that the template is bad. The verdict is that the line between demo pattern and production contract must be explicit. My practical verdict is, use this kind of template to learn orchestration, not as a trust boundary. Before connecting real systems, add a production README that defines the domain boundary, data contract, tool permissions, approval tiers, handoff state, eval suite, trace schema, recovery behavior, owner, policy, and kill switch. The most important upgrade is to follow every side effect. For each write action, ask who authorized it, what data proved it, what policy allowed it, what trace records it, and what eval prevents regression. That is where agent demos become enterprise software. If this review helped you separate agent demos from enterprise-ready agent systems, like the video and subscribe to Fluid Coding and AI. The next useful agent template should not just impress in a demo, it should explain why it can be trusted.